This chapter, we are going to talk about graphing linear functions. Today, we are going to first start by determining what a function is. So, in order for something to be a function, what it is it is a relation that pairs each input with exactly one output. Now, that is the mathematical definition of a function. However, there are some other ways to determine whether graphs or tables or points are also functions. One other way is, in order for something to be a function, the x's cannot repeat. If any of the x values repeat, that relation is not a function. So those are two ways to determine if something is a function. If you are given a graph, a third way to determine if something is a function is whether or not it passes the vertical line test. And we often refer to the vertical line test as the VLT. So if you were to take your pencil on a graph, and if there were any points from the graph on your pencil that occur more than one place, it is not a function. So the first example we are going to look at is if you were to take this graph, if you drew a vertical line anywhere on the graph, it will only cross the points at most one time, so this is a function. The other way of looking at it is if you were to list all of these coordinates as points, the x's would not repeat. If you take a look at number 2, if you take a look at your x values or your input, if you see clearly right away that the x values do repeat, so this would not be a function. Same for number 3. If you just key on the x values, if you take a look at all 5 of those x values, none of them repeat, so this is a function. If you take a look at number 4, because you are given a graph, what you can look at is the vertical line test or the pencil test, as they sometimes refer to it. So if I were to draw a vertical line, if you notice, if I draw my vertical line there, it crosses in 2 places, so this would not be a function. Our last example is a parabola. If you notice this parabola, no matter where I draw my vertical line, it only crosses in one spot, so this would be a function. The next words we are going to talk about are these words called domain and range. The domain of a relation or a function is your input values. Now, your input is just another name for your x values. The range is your output values, or another name for your output values are your y values. So this is very easy if they give you a bunch of points to look at. So in our first example here, you will notice it's a bunch of points. So what we're going to do is we're going to kind of change the directions a little bit. We are going to give the domain, give the range, and we're going to determine whether or not it is a function. So if you take a look for the domain is all the x or input values. So if I take a look, all I do is I list my x or my input values, and that is my domain. It's very simple when they give you points or dots on a graph. The range here are my y values or my output values, so I just go and list my y values. Now if you notice, I just listed them as they were written. You will often see them listed from lowest to highest. To determine whether or not something is a function, you look at all your x values, and if you notice, none of the x values repeat, so this is a function. Even though number 7 is a graph, it is still a graph of points. So if it helps, you can list those coordinates off to the side and treat it just like question number 6. So this coordinate right there is 0, 4. That coordinate is 1, 4, 2, 4. This coordinate right here is 3, 3. This is 4, 3. And this is 5, 3. Once you list those values, then it is pretty easy to list the domain, the range, and the function. My domain, again, is my x values, so I take all of my x values and I list those. My range is my y values, so I take all of those y values and list those. When they occur more than once, you only have to list them twice, or list them once. You do not have to list them twice. And then if you take a look at all those x's, because none of them repeat, this is a function. The next kind is a little bit trickier, because as you notice, it's not just a bunch of coordinates, but it is a bunch of coordinates and everything in between. So whenever you have a graph that is connected between 2 points and not just a list of points, we are going to do the domain and range as an inequality. So I typically like to teach it. Your domain is your x's, so you have to figure out what your x's go from. So you kind of go the furthest to your left, and my furthest left value is -3, and my furthest right value is +3. And we want all the x's in between those, including the points, because those points are shaded in, so they are included. So what we are saying with this inequality is that my domain goes from all the x values in between -3 and 3, or bigger than -3 and smaller than 3, which means all of the values in between. We will do the same kind of inequality for my range, except instead of going from left to right, my range goes from my lowest y to my highest y. So if you notice, the lowest my y gets is 0, and the highest my y gets is 3. So my y values go from 0 to 3, and that is how you write the range. And then to tell whether or not it's a function, you can check that vertical line test, and because it only ever crosses once, this would be a function. Let's try that a couple more times. So in number 9, it's kind of hard to see a little bit, but you will quickly notice that there's a list of points. So the points look like they are these 5 points. So the easiest way is to list those values off to the side. -2, 4, -1, 2, 0, 0, 1, 2, and 2, 4. Once you have those points listed, it is really easy to see the domain, range, and function. My domain will just be my x values, so I list those values. My range will be my y values, and again, if there's more than one that are the same, you do not have to list it multiple times. And then no matter where I draw my line, or if I look at all of my x values, this only it crosses one time for my vertical line test, or if you look, my x's do not repeat, so it is a function. And the next problem, you will notice it is no longer dots, but now it is kind of a continuous graph. So the domain again is my x's, so I go from my smallest x, or my left kind of bound, which is -2, to my furthest x value, which looks like to be 3. And then I do the same thing for my range, but I go from my low to my high. So my low y value is at -1, and my high y value goes all the way up to 2. So my domain goes from -2 to 3, and my range goes from -1 to +2. And then I check my vertical line test. Because it only crosses one place, no matter where I am at, I would also say that this is a function. So my last example is a little bit different, because as you notice, this is different because it now has arrows on it. So dots are listed as kind of numbers. Continuously connected graphs, as long as they have dots at the end, are listed as inequalities. But when we have arrows, we have a tendency to write it a little bit different. So if you take a look, because this arrow goes out and up continuously, it actually goes forever and ever out. So it never stops getting smaller on my x's. There's no real place to stop this way. And it also keeps going forever and ever to the right, and there's no real place to stop this way. So when it goes forever, this way and this way, that means all of these x values are part of the domain and all of these x values are part of the domain, which means every possible number is part of the domain. And when that occurs, we call that reals. So for my y's, you can see that this is as low as it gets, but then it keeps going up forever and ever and ever. So it does not have an upper stopper here. So for my y's, this y value is 0, and the graph gets every other value up above that. So my range here would be y greater than or equal to 0. Next, I draw my vertical line because it only crosses in one spot no matter where I am. I would say it is a function. The last thing that we are going to talk about today is going to be the difference between independent and dependent variables. So an independent variable is a variable that represents the input. And if you notice before, the input we called kind of the x value. And the dependent variable, that represents the output, which we have kind of talked about as the y value. The other thing, if you talk about a dependent variable, it depends on the value of the independent variable. So if we take a look at this, y is a function of x, which means y depends on x. So what we're going to do is we're going to look at independent and dependent variables in some story problems. So if you take a look at this first example, it says the function a equals negative 4b plus 14 represents the number a of avocados you have left after making b batches of guacamole. So if you take a look here, this a is kind of like my y, and this b is kind of like my x. So if you kind of look at the problem, the number of avocados you have left depends on the number of batches of guacamole you make. So in order to identify the independent and dependent, one way to look at it is your independent is always kind of your x value, which in this case is the b, and the b stands for batches of guacamole. And then your dependent is your y, which in this case is your a, and the a represents the number of avocados you have left. So the b, or the batches of guacamole is your independent, and the a, or the avocados you have left, is your dependent. The next question says, if the domain, and remember domain deals with your x values, if the domain is 0, 1, 2, or 3, what is the range? So what this is asking for is if you make 0 batches of guacamole, how many avocados will you have left? So if you plug in 0 for b, negative 4 times 0 is 0, 0 plus 14, the first value of your range will be 14. Then you plug in 1. What if you have one batch? Negative 4 times 1 is negative 4. Negative 4 plus 14 is 10. Then you plug in 2. Negative 4 times 2 is negative 8. Negative 8 plus 14 is 6. And then you plug in 3. Negative 4 times 3 is negative 12. Negative 12 plus 14 is 2. And the other thing you will quickly see is that there is a pattern on your range, and you are decreasing by 4 each time. The next question is similar. The function T equals 19m plus 65 represents the temperature T in degrees Fahrenheit of an oven after preheating for m minutes. So if you kind of think of the T as your y and the m as your x. Your independent is again the m, which in this case is your number of minutes. And your dependent is again your y, which in this case is your T, which is your temperature of the oven. Okay, so the next part of this question says a recipe calls for an oven temperature of 350 degrees. Describe the domain and the range. All right, so this one's a little bit trickier because they don't give you the domain like they did here. They give you another part of it. So if you notice, this 350 is the temperature. So if the oven gets to 350, that means my dependent value of temperatures high value that it could be is 350. So if we know that the high value is going to be 350, what we then have to do is figure out how many minutes it would take to get to that 350. So if we take a look at this problem, you will notice that the 350 is your temperature, or T. So I'm going to plug that in for the T. And I'm going to solve it. So the first thing I'm going to do is subtract 65. And then I'm going to divide by 19. And M equals 15. So in 15 minutes, the oven will get to 350 degrees. So we know that my highest amount of minutes is 15 and my highest amount of degrees is 350. But what if we have not even turned the oven on yet? So what if no minutes have gone by? So if no minutes have gone by, the oven's temperature is, if I plug in 0 here, the oven's temperature would be 65. So if no minutes have occurred, I know that the temperature is 65. From this, I know that 350 degrees is the highest I want to get to, and I know that it takes 15 minutes to get there. So now, the next question you have to ask yourself is, here we were talking about avocados and batches. So in this case, you either make a batch of guacamole or you don't. However, in this case, you could have something in the oven or the oven preheating for 2.7 minutes. So we don't want to list here. We want the domain or the input or X values to be anywhere from 0 to 15 minutes. And we want our range or our output or our Y values to be anywhere from 65 degrees to 350 degrees.